Welcome to the 6th lesson since lockdown. I wonder if you can remember what the other 5 were. Today we're looking at linear sequences. A sequence is a list of numbers or shapes that follow a pattern or rule. And linear means that the sequence will increase or decrease by the same amount each time. Let's see what Barley's been up to. Today Barley's been investigating sequences. So he's made a pattern of tiles. He's got 3 patterns in his sequence so far. He wants to know how many tiles he's going to need to make the 10th pattern in the sequence. Well, first of all, let's just have a look and see how we define each term. So we use the letter N to represent the position of each pattern. So the first pattern, N is 1. The second pattern, N is 2. The third pattern, N is 3, and so on. Barley, where's the third pattern? Good boy! Barley, how many tiles are there in the first pattern? 3, well done! How many tiles are in the second pattern? 5, well done. How many tiles are in the third pattern? 'Barley, how many tiles are in the third pattern? 7, well done. So we've got 3 terms in our sequence, and we're counting tiles. We've got 3, 5, 7. We want to know how many tiles are in the 10th pattern. That's when N is 10. How can we find the number of tiles in the 10th pattern without making every pattern in between? To do this, we're going to find something called the nth term. Start by writing out the sequence, which in this case is the number of tiles. 3, 5, 7. Remember that although Barley has only made 3 patterns, this sequence could go on forever. So after 7 we could have 9, 11, 13 and so on. Then work out the first difference. That's the difference between each of the numbers in the sequence. So between 3 and 5 plus 2, 5 and 7 plus 2. This plus 2 is very important. I'm ringing it in red now. And this means that the 2 times table is going to be very important in this sequence. So write out the sequence 2n, which is the 2 times table. So for the first pattern, n is 1, 2 times 1 is 2. For the second pattern, n is 2. 2 times 2 is 4. And the third pattern, 2 times 3 equals 6. Finally, compare the 2 times table, the sequence 2n, with the sequence that you want. So comparing 3 and 2, 5 and 4, 7 and 6, 3 take away 2, 1. 5 take away 4, 1. 7 take away 6, 1. All quite straightforward so far. So now we put these two things together and we can say the nth term is 2n, the 2 times table, plus 1. We need an extra 1 to make the sequence we wanted here. We could use this nth term to find the number of tiles in the 10th pattern. In the 10th pattern, n is 10. Put this in your nth term. 2 times n now is 10. 2 times 10 plus 1 is 21. That's 21 tiles in the 10th pattern. Why don't you go back and watch the method again to make sure that you followed it?
And if you don't believe it, draw all 10 patterns. Can you find another linear sequence? This is a challenging topic, so why not start by drawing some sequences and send them to me, and I'll tell you whether they're linear or not. For some further questions, why not try Mr. Corbett's worksheet by scanning the QR code here. I know most of you like a challenge, so let's look at a quadratic sequence. Quadratic here means that the sequence will include a square number. Perhaps pause the video and talk to your homeschooler about what a square number is.
Barley's trying a new sequence now, slightly more advanced sequence. Got 3 patterns again. 1, 2, 3. Okay, Barley, where's the second pattern? Good boy. How many tiles are there in the first pattern? Good boy, 4. Okay. How many tiles are there in the second pattern? 9. Well done. How many tiles are there in the third pattern? 16. Well done. We've got 1, 2, 3 positions. That's 3 patterns. And the terms are the number of tiles. That's 4, 9, 16.
So how do we find the number of tiles in the 10th pattern here? Again, we're going to find the nth term. We're going to start in the same way by writing out the sequence, the number of tiles in each pattern. That's 4, 9, 16. Then look for the first difference, the same as before. So between 4 and 9, 5. Between 9 and 16 is 7. So it's not the same, so it's not linear. So you need to look at the second difference. So the difference between 5 and 7 is 2. I've only given you 3 patterns, so we can't look at the difference between other numbers, but it is 2 in this case. You use that 2, so I'm ringing it in red, and I always think of multiplying it by n squared, the square numbers, divided by 2. But a lot of people like to just divide the 2 by 2. In this case it's 1, so we're going to look at n squared. So write out the sequence of square numbers starting with 1. 1 squared is 1 times 1 is 1. The second term, 2 squared. 2 times 2 is 4. The third term, 3 squared. 3 times 3 is 9. I hope you said that before me. Now compare the red sequence with the sequence that you want. So comparing 4 and 1, 9 and 4, 16 and 9. 4 take away 1 is 3. Good practice of some simple mental maths here. 9 take away 4, 5. 16 take away 9, 7. So we need 3, 5 and 7 to add to our square numbers to give us the sequence we want. And this is exactly the sequence we looked at earlier, being the linear sequence. So the nth term is n squared, the square numbers, plus the linear sequence we found earlier, 2n plus 1. So the number of tiles in the 10th term, that's when n is 10, will be 10 squared, so replacing n with 10, squaring it, plus 2 times 10 plus 1, 121 tiles. Once again, why don't you go back and watch that method again, make sure you're happy with it. If you don't believe it, draw all 10 patterns. Can you find any other quadratic sequences? Remember to send them to me. For further questions, go to the Corbett Maths website or scan the QR code here. Wow, well done if you made it this far. That was a really challenging lesson. If you master it now, it'll make your GCSE years very much easier. Have fun.